Good morning once again. We are all welcome to this class. Today we'll still be talking about our PAQ, another method of obtaining our rank matrix, our rank. From there, we move on to reduce row echelon, which is one of the key points. So can you see my screen, please?
Yes, sir.
I need a response from you guys.
Yes, sir, we can see the screen.
Okay, thank you. So
Yes, sir.
For this morning, we'll talk about PAQ. PAQ form this form, we normally use it to obtain our rank matrix, but it has some identity. One of the it has some steps. Let's just put it steps. Number one steps are the both row and column operation are allowed. Remember, on the row echelon, we only use row alone. But in this case now, we will employ the both row and the column. Number two, we let, anytime we have a matrix A, M by N, it always equals to I subscript M multiplied by A of matrix, then I subscript N. Now, listen, I means identity matrix. I means identity matrix. Please take note of that. Then, that is I identity matrix of row and identity matrix of column. Then number three, our matrix, our rank matrix is the same, is equals to, how do you discover it? Is equals to the size of identity matrix. Is equals to the size of identity matrix. Is equals to size of identity matrix. So please note that the row operation only perform on IM, substitute N. Why? column operation are performed on I suspect N. So we have this. Let's look at the question. The question 1 says reduce A to PAQ form and determine the rank. Determine the rank and determine the rank. Let me just put it, let me say, and determine the rank of A. Now, we have A to be, our A is equals to 1, 1, 5, minus 1, 3, 3. Then we have 3, minus 3, 3. We have 6, minus 4, 11. Now, who can tell us the dimension based on the steps we have? We have A to be, remember it's M by N, right? It's going to be, how many rows do we have?
3.
3. How many columns?
3 rows.
How many
4
columns?
columns.
4 columns.
4 columns. So we have 3 by 4, meaning that I can now write my formula to be, remember the formula from up here, the formulas are here. Let's call it formula, so that for some of us, this is what we are going to work with. It's going to be, my IM will be I3, A, then I what will last?
I4.
I4, meaning that I'm to formulate, they will only give you A in this case. You are to write out the identity matrix. For example, the identity matrix for I3 means 3 by 3 matrix. The identity matrix for I4 means 4 by 4 matrix. Please take notes. Then you have your A as your question, which is, we can now work on. We can move on. Now, in this case now, I can go ahead and write it out by saying, my matrix start from 1, 1, 5, minus 1, 3, 3, 3, minus 3, 3, 6, minus 4, 11, equals to, remember from day 1, I'm just using the method, the formula. Look at this formula. I'm writing everything here now out. Equals to the identity matrix. Nobody will give you, you are the one to form it. 3 by 3. 1, 0, 0. Remember, 0, 1, 0. That's identity. 0, 0, 1. So that is identity matrix. For high 3, multiply by A. Then for P is 1, 0, 0, 0. 0, 1, 0, 0. Then 0, 0, 1, 0. The last one, 0, 0, 0, 1. What do we mean by identity? Is the matrix that all the diagonal are non-zero elements. Is the matrix where all the diagonal are non-zero elements. Most times we put 1. We use 1 as the non-zero element. Other parts, both upper triangle, they are 0. Lower triangle, they are also 0. That's what we call identity matrix. So go and read your definition very well. You will see it there. Look at it. You just make this place to be. This is what makes it identity. Take note of that. So don't ask question, how do you now do it? It's there in your book. Take your time to read. Any question before we start solving it? Let me stop sharing. Okay, Temitope. You raise up your hand. Lawoye. Okay. Blessing.
Yes, sir. Please, good morning, sir. I want to ask which page are we on the course material, sir?
Go and check matrix.
I can see rank of matrix, but I can't find this question we just.
Madam, I've told you, I think you are new in this class. I'm to facilitate, not to teach by book, not to be following books. Right in the class. I'm not teaching history that will say, okay, be reading along with me. No. We just pick the topic, I explain it, then you continue from it. That's what they call it, facilitation. They are not saying I should lecture, but I'm trying to lecture and teach you at the same time. So stop reading the the textbook in my class. It's better you write it down. When you get home, you can have cross-check and be mapping it the way you do. Is that okay?
Okay, sir.
Okay. So this is not history. Are you sure you register for this course? Let me ask first.
I did, sir.
Which department are you?
Computer science.
Oh, but you've not been coming.
Sir, I've been coming. The only challenge I've had is from that day one. The first day I asked you the same question. We're following the textbook. All of a sudden, I was lost. You replied me with the same thing. You said that you are solving another question that is not in the course material. So since that day, I've been lost. I only come online.
Okay, let me explain to you so that for you to find yourself, will you be able to solve, because I know what you are asking, you are not the only one. Majority of you guys are asking the same question, but they cannot talk. Let me just explain the way it works. In mathematics class, that is why majority of us find it difficult to pass. We believe that the lecturer should give you the same thing. If I ask question in X, Y, Z, don't expect X, Y, Z in the exam. In the class, mathematics is so beautiful to the point that I can give you 1 now and change it to -1. So if you are the type that always writes the one in the textbook, you will find it difficult. For example, textbook is just to guide you. That's why they call it course guide. It's just to guide you that this is a topic we are treating. In university is different from the polytechnic. Polytechnic will ask you, okay, do the way I put it in the manual, write it down like that. But in university is a universal knowledge, whereby the lecturer will come to class, give you the topic, tell you the subtopics, and go and prepare your notes by yourself. If I may ask you, have you done your TME?
So I've not been able to log in. The portal has been down.
Oh, others have done their own. Which center are you?
Lagos.
Makati, Mushi, or which one?
VI.
VI, okay. How many of you are from VI that are doing computer science?
I only know one of my classmates. I don't know the rest.
Okay, what I would advise, maybe after the class we can talk. Let's continue. Is that
Thank
okay?
you, sir.
Okay.
Yes.
You have my number. You can just chat me up. Then we talk. I will explain better, and you have a better understanding of what we are doing. And peradventure, we have others that are facing the same challenge. Feel free to chat me up. Is that okay? Let's continue. Okay. Now, okay. The question I'm asking: how many of us is finding it difficult? You get the? Do you have? At this point we are in now, do you understand it? Where I formed the question. If you know you are facing challenge, raise up your hand so that I can quickly treat that before we solve the question. Silence means we are all, silence means no problem. Okay. Yes, Apan. Unmute yourself. Apan.
Good morning, sir.
Good morning.
Sorry, sir. I want to say something about this. We have a. I mean, you are forming two metrics here. One is a 3x3, and the other one is 4x4.
Yes.
Is there no way we can use one? I mean, to cover both of them.
You want shortcuts, right? Okay, noted. I will explain to you. Let me ask the other guy. There's another guy raise up the hands. Or are you guys asking the same question? Okay. Let's continue. Let me share my screen again. Let's go back. Apan asked us to use one instead of two, right? Okay. Remember, in mathematics, we deal with steps, we deal with formulas. Look at this. You were there when I was giving them this. This is the formula. The formula says matrix M by N is equals to IM multiplied by A multiplied by IN. There's no shortcut. The only shortcut in this case is straight line. Follow the instruction. Now, you and I know, I've explained that anytime you are performing on your A by NM, anytime you are performing any operation here, you must do the same thing. Let me just remove this element. Okay. So that you will not be confused that what is this man trying. Anytime you are performing any problem, any operation here, if you are performing row here, remember I just told you, I3 will take what? Row operation. Just put it there for your own good. Why? I4 will take column operation. So this is our main question. A, M by N, right? AM by N. Anytime I'm performing any operation, if I'm performing row operation on AM by N, I must come here and do the row too. I will leave this one constant. If I'm performing column here, I will leave this one, I'll keep this one constant, and I will come here and perform column. Please take note of that. Our aim in this case for PAQ is to make this particular to be identity matrix. That is why when Tayo was asking a question that is there any particular unique thing we are looking for? For example, this place now, we are looking for identity matrix. How can we make this one to be identity matrix? This particular one that I'm dotting, how can we make it identity matrix? That is our target. So we need to, that's why if you check the steps, is stated here. It says the size of, it said rank of A is equals to size of identity matrix that you are able to get at the end of the day here. So let's continue. Okay, let me ask us again. Now, for us to solve this problem now, who can tell us what to do first? We are starting the operation from here. Who can tell us? If you want to talk, just, okay, unmute yourself. Okay, Deborah.
Yes, sir. To get to column 2.
Column 2.
Yes, sir.
Remember, row come first.
Oh. Okay. So we do row 2, we give us row 2 minus.
Now, for row 2, we lead to what?
Row 2 minus row 1.
Row 2 minus row 1. Do we agree? Then another one, row 3. Row 3 will lead to what? Row 3 will lead to what?
Row 3 minus 5 row 1.
Now, don't forget that you have another operation the other side, which is, this is row, and let me just put this is column. Take note of that. Meaning, I'm going to keep the one of column constant. Like Apan says, that can we just use one? No. The two of them will be there, but you only use one per operation. Okay, let's solve it. Let's solve the one of row first. Let me just do the side. Let me write it down. Remember the row row 1 will still keep its own identity since the entry point is 1. Okay, so for row 1 now, we say row 2, meaning this row minus row 1. So meaning that the first one is, let's pick row 2. 1 minus 1 is equal to what? 0. Put it there. Then another one, another element, 3 minus 1 is equal to what? 4. Put the 4 there. It's very simple. Then another one, minus 3 minus 3 is equal to what? Minus 6. Put it there. Then another one, minus 4 minus 6 is equal to minus 10. That's all. We finish that one. I can claim this one, your own.
Sir?
Yes.
That in that row 2 column 3, you have minus 3 minus 3.
Where do you see minus 3, bro? This
That
is
row,
minus 3.
that row,
Row 2, right?
it's supposed to be -3 minus -3, which is
There is no minus
-3
here,
plus.
bro. This is positive. This is positive. You only say -3. The operation there is minus. Put it there. That's why you see minus.
Okay.
You can't introduce another minus to 3 because 3 does not carry minus, it's positive. Is it okay?
I was thinking.
Don't
Yes,
think,
sir.
go follow the question, bro.
Okay, sir. Thank you, sir.
You're welcome. That is why I put it. Nobody is interested in this side corner of calculation that I did, arithmetic. So the next thing is row 3. The row 3 will be, the first element in row 3 is 5. Minus 5 multiplied by 1. 5 is 0. Put it there. So the next element is 3. 3 minus 5 times minus 1. Any question? Five times minus 1, it becomes -5, which is equals to what? 8. Put it there. So the next thing is 3. Five times what? 5 times 3. 15 minus 12. The next thing is 11 minus 30 minus 19. So you put it minus 19. Any question, please? So you continue, equals to, remember the next identity, which is I3, you have to perform row again. You do the row again. We keep this one because the entry is 1. This one will be the same. You don't need to perform anything because it's not column. So for this row now, for this row operations, somebody is raising up the hand. Boyega.
Sorry, I want to ask. The first one, is it the first one we just did now? That is it still identity of 3? Identity of 3 of column this thing.
Which of them?
This first one we just solved now. This R2 minus R2 minus R1, and then R minus 5R1.
We've not done the other side. We want to do the other side now.
Okay.
I've not filled the row. I just quickly write this one out.
Okay.
We are solving it. We can't leave it this way. So remember, it's R2 minus R1. So it's going to be, what's the first R2? 0 minus 1. What's the answer? minus 1. So we write minus 1 there. Then the next one is 1 minus 0 is 1. The next one is 0 minus 0, 0. Then R3 minus 5R1 will be R3 is 0 minus 5R1. 5 times 1 will be 5 equals to minus 5. So this is minus 5. 0 minus 0, 0. Then the last one, 1 minus 5 times 0, 0 equals to 1. Any question? You can see we perform the operation now. Now, let's look at the question. Remember, we need to perform column 2. Let's look at the column. Which of the column do we need to deal with? How do we make, remember our target is identity matrix. So everything here, how do we turn them to be 0? For us to achieve our aim. Remember, they are column. That is column 2, column 3, column 4. So let's start from column 2. Said column 2 will lead us to what? Anybody?
Sir.
Yes.
C2 plus C1, sir.
C2
plus C1. For C2, sir.
C2 plus
C1.
C1. Okay. That's first one. Then
Yes.
what happened to C3?
C3 plus 3C1.
Plus.
No, minus 3C1, sir.
Minus 3C1. Okay. Next.
C4.
C4
will be equal to C4 minus 6C1.
Correct. So this is kind of operation. Who is not clear to raise up your hand here? What we are doing. Silence means it's clear. We should continue. Okay. Now, what we are doing is, how do we make it? Remember the way I define the identity matrix is in your notes. If you want to read it, go and read about definition of identity matrix. So for this case now, we can write. Let's perform the operation now. The first column will be, we will not touch the first column because it has nothing to do with what we want to do. How do I know? Entry point is 1. The one that follow it, they are zeros. So for us to deal with C2 now, our C2 will be, let me just open this. C2 will be, let me write it. The first one is minus 1 plus 1, because our C2, this plus this, that's what we are doing. So C2 is minus 1 plus 1, which is equals to 0. So this one, the first entry is 0. You deal with it columnly before you move to another row, another column rather. So you pick another one. C2 is 4 plus 0 is 4. Then 8 plus 0 is equals to 8. So the following one will be 4, 8. Just deal with them gradually. Don't rush yourself, or else you miss the step. So we finish this row, this column now. I can now go to 3. C3 will be 3 minus 3 times C1. C1 is 1. 3 times 3, 1 is 3, equals to 0. You come here, you put 0. Then we have minus 6 minus 3 times C1, 0, equals to minus 6. The next one is same C3 minus 12 minus 0 equals to minus 12. So we have it to be minus 6 minus 12. Any question? You do the same thing. You do the same thing to C4. Our C4 is, for C4, we have it to be 6 minus C1 again. Everything multiplied by C1. 6 multiplied by C1, 6 is 0. Put 0. Then minus 10 minus is 0. It's still minus 10. Minus 19 minus 0 is still minus 19. Don't bother yourself about, oh, this figure is bigger. No, it's getting bigger, it's getting bigger. Just continue. So any question, please? So we have it to be, we can continue on our own. So the next identity, the next other side now, what we need to do is just to keep it like that. It's going to be constant. You don't touch it because it's only meant for a row operation. Don't forget. A, then you have this one. Now, we now do the row operation, column operation on this one now. Don't, is the column operation 1, 0, 0, 0. So the column, let's start from column 2. C2 plus C1. C2, 0 plus 1 equals to 1. So don't add 1. Then the next one, C2 again, which is 1 plus 0 is equals to 1. The other one, they are zeros. 0 plus 0, 0 plus 0. Then for C3, let's solve the C3. C3 is 0 minus 3 because it's 3 multiplied by 1 is 3, which is minus 3. Then C3 is 0 minus 0 equals to 0. C3 is 1 minus 0, which is 1. So this is 0, this is 1, and the last one will also be 0. Then for C4, we have 0, 0 minus 1. Our 1 is 6, right? Which is minus 6. This is minus 6. Then the next one is 0, is 0. Then we have 1 minus 0 equals to 1. The last one will be 1. Any question, please?
Sir, mine is not a question. That should be the final answer.
I can't hear you.
I'm not asking a question. I want to just say what you just wrote now is the final answer.
For what? It's not final answer. Remember, you are moving. This is what we are working on. Actually, this is, I've told you, we want to make this one. It must be identity matrix. Is it identity matrix now?
No, sir.
So until when the left hand side turns to identity matrix, that is when you have a final answer.
Okay, sir. Thank you.
Have I made myself clear now? So now the next question, the next thing we need to do is, how do we make, this guy is just making me laugh. Because when you ask from here, is that final answer? It's not at all. So now I quickly want to perform something. If you check very well, the column 2, how can we make column 2? Remember that, look at this, from this. This is where we are going. How can we reduce column 2 to be 0, to be 1? Because that middle point, that diagonal element must be 1. How can we do that?
We can, Elazar,
Go ahead.
we can divide by 4, sir.
Which of them?
The column 2.
Column 2. I believe we all agree. So let's quickly perform that operation. Our C2 will link to C2 divided by 4. So meaning you're still going to perform column 2 all through now. 1, 0, 0. So C2 divided by 4, 0 divided by 4 is 0. This one turns to 1. This one turns to what? 2. The rest will remain the same because we are not working on them. Which is equals to 1, 0, 0 minus 1, 1, 0 minus 5, 0, 1. Then A is here. So this one too, 1, 0, 0, 0. This particular one is C2 divided by 4, meaning 1 divided by 4, then 1 divided by 4, 0, 0. This will be minus 3, 0, 1, 0. This is minus 6, 0, 0, 1. So we can continue. Yes, those of us raise up our hands, ask question.
Oh, sir. Can we decide to divide our row by row 2 by 1/4? I think we can still have 1 for that second column also.
Row 2 divided by 4.
Yes.
But can 4 go in 6?
No, sir.
That
Okay.
don't complicate the matter for yourself.
Okay, sir.
Because you look at it, which one will not give me those, because my target is just to have identity matrix.
Okay, if the role is simpler, it is better we can use it.
You can use the row. If it is
Okay,
column that
sir.
is simple for you, use the.
Okay, sir.
Any other question? Okay. Now, let's perform another operation. Which one do we need to reduce? Row or column?
Column, sir.
No.
Row.
It's row because you already have. Let's see how we can maintain the one we have and be able to push it further. Now, we need one in particular place, and we need, you understand my point now? Let's continue.
Okay.
I know what you mean by row, but as for me, I will start from row 3. I can say row 3 will be what?
Row 3 minus 2 row 2. 2 row 2.
Minus 2 row 2. Simple. Row 3 minus 2 row 2. Why? Because I know I need to make this particular 2, this 2 to be 0. How do I know? Because I know some of you are asking questions. Remember, we are looking for identity matrix just to make some particular element to be 0. Thank you. So I can go ahead by saying one, 0, 0, 0. Then 0, 1 minus 6 minus 10. Then the last one will be, so let's say row 3 now. We are doing row 3 will be, row 3 is 2 minus 2 multiplied by 1. 2 equals to 0. We are just multiplying. Remember, this one said 2 row 2. That is 2 multiplied by row 2. Then the next one is minus 12 multiplied by minus 12 again. Because 6 multiplied by 2 is 12 with negative, minus times minus plus. We have 0. Then we have the last one will be minus 19 minus 20, which is 1. Any question? Silence means no question. Thank you. Equals to, remember you have to perform the same operation, the row operation here. So we have 1, 0, 0, minus 2, minus 1, 1, 0. The row says, row 3. Yes, Boyega.
Sorry, when you are performing this is on the roll, this last one we are doing now. When you're performing row 3 minus 2 row 2, you didn't perform it on the this thing on the elements of 100. That is the beginning of the this thing.
No,
The beginning of the matrix.
remember,
Why?
nothing. You have nothing to do with row 1.
Okay.
You from the operation you mentioned now. Do you see row 1 there?
No. You didn't.
So you won't touch row 1.
Okay.
You only deal with the row that
row
is
1 is not
concerned.
part of the this thing. Row 1
Yes.
is not part of the matrix. Okay.
No, it's not that row 1 is not part of the matrix, but it's not part of the operation at that particular time.
Okay.
Just a minute. So row 1 is not part of the, row 1 is good, but we are not using row 1 for this operation. So let's continue. Then for row 3 now, we have it to be, we have 0 for row 3. No, we have 5 rather, sorry. We have -5. We are talking about this now. We are talking about this side. We have -5 minus, in brackets, minus what? 2, which is equals to -3. So you put -3 here. So the next thing is 0. We have 0 minus 2, which is equals to -2. It's -2. You have 1 minus 0, which is equals to 1. Any question? Any question, please? Okay. So you keep the others constant. Don't forget, other metrics, you keep them constant. You just move on. So we have our A will be back. Then write this one 1 0 0 0 1 all over 4 1 all over 4 0 0. Here you have -3 0 1 0 -6 0 0 1. So let me stop sharing. Okay, Frederick, you still raise up your hand.
No, I never dropped my. I didn't drop my hand the other.
Okay, please drop it once. I believe you copy. Just okay. Hold on. Let me just answer this. Okay. Thank you, everyone. Can we? Sorry for the interruption. So, with what we have here now, can we? Any other question before we proceed? Okay, I believe there's no question since Nobody is talking. It seems no question. So what other operation do you think we can perform on this? What other operation do you think we can perform now? Column or row?
Column, sir.
Column. Okay, thank you. For column what? Column 3, right?
Column 3, sir. Yes, sir.
To be column 3.
Divide by minus 6, sir.
Is what?
Divide by minus 6.
Divide by minus 6. Okay. What again? What other option do we have?
Okay, column 3 plus 6 column 2.
Better. Plus 6 column 2. Yes. Then
Column 4
column 4
is equals to column 4 plus 10 column 2.
Good. Okay. So Boyega.
Sir, I actually want to ask, is it possible we do this column before the row? We must, in this particular situation, we must do the row first before the column, as in
No, you can see that
with the respect of the row, the first the one we did last now, like row 3, this one we did. Is it possible we do this column 3 before the row, or it must be the row before the column? Since we've done the row, since we've done column first before, since we've done
take
column.
for example, look at the up here. You
Yeah.
look for the one that is convenient
Okay.
for you, and
Okay.
that will not make it complicated.
Okay.
Most times, so far the rows and column are allowed. When Tara was giving me the answer now, I said, check it again. You have to reason. This is why you have to reason. They just want to broaden your knowledge here.
Okay.
That, okay, what other alternative do I have? I'm a computer engineer. Now, if they bring any problem to me or I'm to resolve problems, what other route do I know? Which one will make my work easier?
Okay.
This is the purpose of, and if, for some of you, you are into programming, there's nothing you want to do in programming without MATLAB, without a matrix. You use binary operation, 0 and 1. So let's continue. So these are the applications we are talking about. Now, for this one now, we can say we are working on column. For if you are working on column, how do we do it? So let's start. We know that our first column will remain because we didn't mention it here. So let's see C3. And then our second column also will remain because it's the one we are using as a multiplier. But the one we are performing on is column 3, C3, and C4. So let's work on C3. For C3, we have 0 plus C2 times minus 1. C2 times minus 6, rather, is still minus 6. Am I right?
Yes, sir.
C3, sorry, okay, still is this 0 in this case, which is equal to 0. So let's do the second one. We have minus 6 plus C2, which is what? Any question? C2 is what? Anybody?
One.
One times, you said?
C2 is 1.
Is it going to be 1?
No, it's going to be 6 multiplied by 1, which is 6.
Which is 6. So it's going to be 6 here. Which is equal to 0. We've achieved that aim. And the last one will be what? 0. So let's do the C4 too. C4 will be 0. This will be minus 10 plus 10, 0. It will also be 1. One plus 0, which is 1. So equals to, remember we are working on column, so not row. We keep the row constant in this case. So our row will be in constant in this case. We have 1, 0, 0. We have minus 1, 1, 0, minus 3, minus 2, 1. We have A. So in this case now, we perform the same column. Column 1 will remain is sanity. Then column 2 will also follow the suit. 1 will be 1 all over 4, 1 all over 4, 0, 0. So column 3, we work on column 3 now. Column 3, for us to work on column 3, we have C3 to be minus 3, plus 6 multiplied by 6 over 4. What is minus 3 plus 6 over 4? What do we have, please? Anybody? Nobody is talking.
Minus 1.5, sir.
Which is minus 3 over 2. Am I right? So,
yes, sir.
Okay. This will be 0, and this will be 1. Please calculate it out the way I did now. So the last one will give us minus 3 over 2 also, 3 over 2, 1, and 0. Any question? Any question? Silence means no question. Now, let's now do something here, the last stage. For somebody that is waiting for the answer, here's the last stage. How do I know? Look at this element here. This particular matrix is already reduced to identity, but it's not really identity this way. If you check column 1 is fine, column 2 is also fine, column 3 is 0 or true. So I can interchange between column 3 and column 4. I can now say C3 will be C3 interchange C4 is allowed because it's all the entry are 0. So we have it to be 1, 0, 0. This one will be 0, 1, 0. I can switch now, 0, 0, 1, and the last one will be 0, 0, 0. So here is 1 minus 1 minus 3, and we have it to be 0, 1 minus 2, 0, 0, 1, A. We have 1, 0, 0, 0, 1 all over 4, 1 all over 4, 0, 0. Interchange, you can also interchange here the way it is, because we are performing column operation, which is minus 3 over 2. It's still the same thing there. Here 1, 0. Here is minus 3 over 2, 3 over 2, 0, 1. So from here now, we can conclude that we have our identity matrix. You and I can say there is identity matrix. Let me pick this pen. Here is my identity matrix now. And here I can call this one P and Q. So this is our identity matrix. So who can tell us the rank of identity matrix here?
The rank is 3, sir.
The rank is what?
1.
1. Okay, somebody
Yes,
say
sir.
1. Good.
Yes, sir. 1, sir.
The rank is what again? 1. How many of us believe it's 1?
Is 1, sir.
Is 1. Okay. Why is it 1?
It's 0, sir.
Is 0. Good. Why is it 0?
That's 3.
Let me answer before I'm coming to you that say 3. Somebody says 0, somebody say 1. You are saying 3. I don't know. So why is it 0, bro?
Hello, hello, sir.
Yes, I can hear you.
The answer is 1 because the row of non-zero,
We are waiting. The row of no 0. I'm hearing you.
non-zero is it should be 3, sir.
It's 3. You change your mind. Let me ask another person. The man that said is 0, please tell us.
It's because there's no non-zero row.
All of them, they are 0, right?
No. It's not all of them that are 0.
Okay, how many?
I mean, there's none that is 0.
What is the definition of rank? First thing. Anyway, the answer is okay. Tell us, Deborah.
The number of non-zero rows.
The number of non-zero rows, which is what? 3. Do you agree with us? Is 3?
Yes, sir. Yes.
Because that is why we interchange this one. We send it away because it will jeopardize our answer since we can switch also. So you can see the number of row 0, row 1, row 2, and row 3. And that's make it 3. any question? Now, we call this one. You have a question?
Sam, what's the essence of the PAQ on the right hand side?
Good. P and Q, they are just no singular metrics. No singular metrics, they are the metrics that anytime you find their determinant, will give you identity metrics. So we use it just to guide. That's method. You know, it's all about method. You might not know the application as we are talking now, but when you get to the real world, there are applications of it, especially in engineering, in computer programming, some of us in computer science, and other field. Apan.
Yes, sir. Sir, please, I want to ask a question now.
Go ahead.
Please, what do you say our rank of this metric is now?
I didn't say it. The solution say it. What is, let me ask you yourself first, what is the rank? Do you know the rank? What do we mean by rank?
So I think it's the maximum number of linearly independent row in a matrix.
Linearly independent row. Okay. And what are the linearly independent row? When they say linearly independent, it means what?
It's talking about, okay, wait.
No, don't stop. Oh, I want to hear you. So when we are talking about metrics, a rank of the metrics is when you have non-zero. How many non-zero rows do we have after your reduce, when you reduce it? How many non-zero elements do you have? Non-zero row do you have? You discover that in this row now, we have 1, 2, and 3. So that is why we use 3. That's why we call it 3. Assuming all the last row, they are 0, including the column. So we will only have 2. Assuming the 2 after reduction, the 2 rows are 0, we only say 1. I hope I've answered your question. Okay, let me stop sharing. I believe you copy it. So any question? Is it interesting? Is it interesting? Open your video. Let me see your face. If you can open your video, open it. Okay. Is it interesting?
It's interesting, sir.
Okay. By fire, by force is interesting, right?
I've